recording the session. Okay, so I'm going to go ahead and share my screen. Okay. So on today, guys, we are continuing our topic into trig because we want to understand how this applies to physics. So hopefully everybody got the opportunity to watch the video that I posted on Tuesday. Well, for a lot of you guys, that should be simple review. I know, especially for those of you guys that have Mr. Becksmith, this is something that you guys know very well. This should be review to you guys. However, a lot of you guys you're also seeing this for the first time. So please be sure you're paying attention while we're going over this because, guys, trigonometry is very, very important. Not only do you use it in your math classes and your physics classes, but like for those of you guys who are going to college and you're going to study some sort of engineering or physical science, you will be using trig. It is super, super important. Okay, so just FYI, something to keep in mind. So it is seventh. So click on the link for seventh period. Today is Thursday. Okay. All right, guys. So here's what we're going to do. We're going to start off by going over this PDF file together, just to be sure everybody knows how to label all the sides of a right triangle. And then this right here, the trigonometric problems, this is what we're going to be working on together as a class. Well, some of the problems we're going to be working on together as a class. The rest of them you're going to finish on. The rest of them you're going to finish up on your own. And so as soon as you guys get done with that, you're going to take a picture of that and upload it into the submission box here. Because once you guys upload those into the submission box, that's when I receive it. Okay, so that's the goal for today. Let me start a new commie file. Okay, so trigonometry. Okay. Whenever we are working on trigonometry, of course, as you all know, for those of you guys who are familiar with this, there's an important acronym that you guys need to remember. And that acronym is Socatoa. So Socatoa. And this acronym is important for remembering three equations. And the first equation you guys need to know, I'll write this down here, says that sine of some angle theta is equal to the ratio of the opposite side over the hypotenuse for a right triangle. Okay, that's the first equation you guys need to know. The second equation you guys need to know says that cosine of some angle theta is equal to the ratio of the adjacent side to the hypotenuse for your right triangle. And then the last equation you need to know is that tangent of some angle theta is equal to the opposite side over the adjacent side for your right triangle. So guys, you're going to use one of these three equations to work out these specific problems. And again, the acronym Socatoa helps you remember that. Right? Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent. Socatoa. That's the acronym you want to remember whenever you guys are working these problems. And of course, guys, hopefully you guys have a calculator next to you all, or if you don't have a calculator next to you all, please feel free to use the calculator in Google. Just go to google.com and type in calculator and then press enter. Okay. And so as you guys can see here, when we click on our calculator, here's our sine function, cosine function, and our tangent function. Okay, so we clearly see those here. And also, guys, one more thing about before we start doing these computations, you want to be sure that your calculator is in degrees and not radians. So I'm gonna press degrees here just to be sure we're in degrees. You want to be in degrees and not radians. Okay. Now, with that said, let us go to this first PDF file right here, just so you guys understand how to label all the sides of a right triangle. Let me pull that up now. And I want you guys to be helping me with this, because I know many of you guys know this. Okay, so guys, before we start using these mathematical equations, I want to be sure everyone in here knows how to label all the sides of a right triangle. Okay, so we have a right triangle here, and we have some angle theta. Okay, and we want to be able to reference these sides relative to this angle theta. How do we do that? Okay. Can someone tell me, first of all, this side in blue, what side is this? Is it my adjacent opposite side or my hypotenuse? Can someone tell me? Yes, thank you, Courtney. It is the opposite side. Okay. And guys, what I need for you guys to remember is that anytime you see this angle right here, this angle theta, the side that is always across from this angle is what you want to label the opposite side of your right triangle, right? Because it's opposite this particular angle right here. Okay, so that's what we mean when we say the opposite side. It's across from this particular angle. Okay. Right here in green, guys, what is this side in green? This is the longest side, so everybody here should know what this is.
It's the hypotenuse.
Yes, ma'am. Thank you. It is the hypotenuse. Yeah, so the longest side of your right triangle is always your hypotenuse. Another way to remember this is the side that is always opposite your 90-degree angle is your hypotenuse. And obviously this side in red will be our what? Our
Adjacent.
Yep. Thank you. And thank you, Jade. It would be our adjacent side. So guys, the way you remember that, guys, the adjacent side is always the side that is directly touching your angle theta. In other words, it's directly next to it, right? Because that's what adjacent means, next to. So it's next to our angle theta. So it's touching it. It's next to it. So this is always our adjacent side. So the adjacent side is always touching your angle. It's next to your angle theta. The opposite side is across from the angle, so relative to this perspective. And the hypotenuse is always the longest side of your right triangle. It's the side that is across from the 90-degree angle. Okay. So guys, this is true no matter what the orientation of your right triangle is, or these things are true. Okay, so let me see that there labeled. Okay. Now, guys, let us look at some more examples. But this time, I'm going to switch the orientation, and I'm going to switch the location of some of the angles that we're analyzing. For example, let us look at this one right here. Okay. So, guys, look at this right triangle. Notice how this right triangle is oriented this way. Okay. And guys, notice I'm labeling this right here, this side here. That is my angle theta. Okay, so that's some angle theta. Okay, can someone tell me, relative to this angle theta here, what is this side right here? What would I label that along here?
Would you label it adjacent? Or would
Yes,
you spell it?
it is the adjacent side. Exactly. Now, guys, yesterday some students were saying this was the opposite side because they were thinking relative to this point right here. Like, no, you're looking at the sides relative to the angle that is labeled on the problem. Since right here, we're labeling this adjacent. I'm sorry, since we're labeling this theta, then the adjacent side is always the side that is touching that angle, right? So you notice this side is directly touching this angle here. In fact, it's next to it. That's what adjacent means, next to. So that this right here will clearly be our adjacent side. Which means this right here, this side must be our what? This side must be our, sorry. This side is our what?
Opposite side.
Yep, our opposite side. Exactly. Because notice this is our angle theta and it's directly across from it. And obviously the longest side is the hypotenuse. Okay. All right, guys. Let's do some more practice with this just to be sure everybody got this before we actually get to the math. Because if you guys don't understand this, you're going to struggle with the math. Okay. What about this? Let's label all the sides of this right triangle. Okay. So notice this right here. This is our angle theta. Okay. So, what is this right here, guys? What is this side right here?
Opposite.
Because it's across from the angle theta. And what is this side right here? That should be obvious.
The hypotenuse.
Yeah, this is the hypotenuse, right? Because it's the longest side, and it's also the side that is across from the 90-degree angle, which means this side right here must be our adjacent.
Adjacent.
Yep, it's the adjacent side, exactly. And it's adjacent because notice it's directly next to the angle. It's directly touching it. It's next to, it's touching this angle here, right? So this line right here touches this angle. So it's the adjacent side. All right, I think you guys got this. Let's do a couple of more, just to be sure. Okay. So if this right here is my angle theta, okay, what is this side right here?
You're adjacent.
Thank you, Jasmine. This side right here?
Opposite.
Yep, because it's across from the angle. And lastly, this side will be your hypotenuse because that's the longest side of our right triangle, and it's the one that's across from the 90-degree angle. All right, guys, let us do one more here before we get to the worksheet. Just do one more. Consider a right triangle oriented like this. So here, so in this situation right here, so if this is my angle theta, okay. What is this right here, this side right here?
Opposite.
Yep. Because notice it's across from the angle. Okay. And then this side right here will be
Adjacent.
adjacent, yep. Because it's, notice this side right here, this entire side is touching that angle. Okay. Which means this right here, the longest side is my hypotenuse. The longest side of my right triangle is always my hypotenuse. Okay. All right. So I think you guys got this down. With that said, let us get to some math problems. Okay. Where we're going to actually use these equations, Socatoa. Okay. So this is where you guys pull out the sheet of paper and there's something right with, because we're gonna do several trigonometric problems. We're gonna do a few of them together, and the rest you're gonna finish on your own. Let me pull this up. All right, guys, give me just a second while I clear this screen here. And I'm gonna share my screen again. Okay. So for this assignment here, it says find the missing variables. We have several right triangles here, and they're labeled from triangle A all the way to the triangle Q. Okay, so A through Q. All right. So this is just to help get you guys practice in how to do this, so you guys understand your trigonometry. Okay. Um, Guys, we're going to start with letter A first. We're not necessarily going to go in a particular order. I might skip around. So if you guys are doing your work, if you want to skip around, that's fine, as long as you include all the letters. You don't have to worry about drawing the right triangle. I do want to see I want to see that you're showing your work and giving me your answer. I want to show your work because I want to see that everybody understands which equation to use. Sine, cosine, or tangent. Okay. All right. So guys, here's how you do this. Whenever you're solving for these missing variables, in other words, in situation A here, we want to know what is the length of this side here of our right triangle. In order to solve for these missing variables, here's what you guys need to do. Okay. The first thing you want to do is you want to start off labeling everything important on the right triangle. So what you want to label your angle theta, you want to label the side given, and you want to label the side that you're looking for. Okay. Once you've done that, labeled all those variables, you're going to come here and you're going to select from these three equations, you're going to select the one equation that relates all three of those variables, and then you're going to use that to solve the problem. Okay. So, for instance, let's start with situation A. And it's just always helpful to do examples. Okay. So look at situation A. Remember I said the first thing you want to do, you want to label everything that's important to the problem. Okay. So we're told the value of this angle here, this angle theta, we're told that that's 28 degrees. Okay. Notice we're also given this side here, which has a length of 10 units. Guys, what is this side right here? What do I label that?
Hypotenuse.
Exactly. I label that the hypotenuse. So you want to label everything important to the problem. Okay. So you want to label what's given, and you also want to label what you're looking for. So what is this right here, guys?
The
X.
opposite.
The opposite side, exactly. I don't have to worry about labeling this side because notice there's nothing there, so it's not important to the problem. Okay. Now, the question is, out of those three equations that I gave you, which of those three equations relates the angle theta to the opposite side and the hypotenuse? So in other words, which equation includes both these two terms, sine, cosine, or tangent?
Sine.
Exactly. Does everybody see that? The sine equation includes both the opposite side and the hypotenuse.
Definitely. I definitely said so.
I'm sorry?
Oh, nothing.
Oh, yeah. So sine relates the opposite side and the hypotenuse to the angle theta. So we're going to use the sine function to work this out. And this is how you work out letter A. Okay, so guys, looking at letter A, remember what we said we're using the sine function. So sine of some angle theta is equal to opposite over hypotenuse. Okay. So once we selected our equation, now let's just fill everything in. We know our angle is 28 degrees. So sine of 28 degrees is equal to We know what the opposite sides we're looking for. That's x. So I'm going to put x there. And we know the length of our hypotenuse is 10 units long. So I'm going to put 10 there. Okay. So sine of 28 is equal to x over 10. Someone tell me, how do I solve this equation for x? How do I get x by itself? Yeah, I know y'all know this.
Multiply by 10.
Multiply both sides by 10. Thank you, Courtney. Right, because if I multiply the right-hand side by 10, that goes away. Whatever I do to one side of the equation, I have to do to the other. So 10 times sine of 28 degrees is equal to x. Everybody follow me? So if I come over here to my calculator, guys, here's how you put this in. If you notice, I have to be in degrees, and I'm just going to type in 10 times sine of 28 degrees, close parentheses. When I press equal, I get 4.69, which, you know, I'm around to the nearest tenth. I'm going to say that's 4.7. So x is equal to 4.7. Any questions on letter A? Any questions on letter A? Okay, guys, let's keep going. And again, I'm not going to necessarily be working in any particular order. I'm going to kind of be skipping around. Let's see, which one do I want to do next? Again, I'm just going to do a few of them just so that you guys get the point. You know what, guys? Let us do letter G. Let's do letter G. So remember, guys, whenever you're doing this, the first thing you want to do, you want to label your side. Well, you want to label your angle theta, and you want to label all the sides that are important to the problem. Okay. So basically, you want to label what's given, and you want to label what you're looking for. So this side right here is obviously our what, guys? It's our longest side, so that's our what?
Hypotenuse.
Yep. So I'm gonna label that. What about x? What side is x?
Adjacent.
Because it's directly touching the angle. And you don't have to worry about this right here, guys, because there's nothing there, so it's not important to this problem. So the question is, guys, out of those three equations, which three equations relates the angle theta with the adjacent side and the hypotenuse? So sine, cosine, or tangent? Cosine, exactly. Thank you, Jasmine. All right, because cosine includes both adjacent and hypotenuse there. So since we're dealing with the adjacent side and the hypotenuse, so we're going to use the adjacent equation. So adjacent, what am I doing? Cosine of some angle theta is equal to adjacent side over the hypotenuse. Okay. So now, guys, the next step is just to fill everything in. Okay. We know our angle here is 45 degrees. So cosine of 45 degrees is equal to, the adjacent side is x. The hypotenuse is 3. Oh, by the way, guys, this is the letter G that we're working on. Just be clear. We're working on the letter G. And of course, y'all know how to solve this for x. So I multiply both sides of the equation by 3. Multiply that by 3. That goes away. Whatever you do one side, I have to do to the other. So 3 times cosine of 45 degrees is equal to x. So you guys follow me? So if I come over here, if I type in 3 times cosine of 45 degrees, of course, closest parentheses here, I press equal. Notice I get 2.12. So, of course, I'm going to round that to 2.1. So that is the letter G. Any questions for me so far? Are we cool on what I'm doing? All right. So Andrea, you said you know? You're good? Oh, you said no. You said no. No, you don't have any questions. All right. So, all right, awesome. Let me see. What do I want to do now? What's another one I should do? I guess I could do one more, and I'm gonna let you guys pick. Okay, K. That's K. Andrew, I was literally just thinking of that. I was literally just thinking of K. Let's do that one. I was just about to say that. Okay. Okay. I got. So look at K. So remember, the first thing you want to do, guys, you want to label everything that's important to the problem. You want to label your angle theta. You want to label what you're given, and you want to label what you're looking for. So this angle here is 55 degrees. So that's our angle theta. Okay. Which means what this side here that has a length of 15. What are we labeling that?
Adjacent.
Yep. We're going to label it our adjacent side. What are we labeling this right here?
Opposite.
Opposite, exactly, because notice it's opposite the angle. Okay. And we don't have to worry about labeling the hypotenuse because there's nothing in there. It's not important to our problem here. So in order to solve for x, guys, we need to know which of the 3 trig functions relates the angle, the opposite side, and the adjacent side. Which of those 3 functions when you look at it, guys? Tangent. Thank you, Jasmine. Right, because tangent clearly includes the opposite side and the adjacent side. Okay. That's pretty clear. Okay. So tangent of some angle theta is equal to opposite side over adjacent side. Tangent of some angle theta is equal to the opposite side over the adjacent side. So now let's just fill everything in. We know our angle is 55 degrees. Okay. Our opposite side is x. The adjacent side is 15 degrees. I'm sorry, not 15 degrees. It's as a length of it's 15 units long. Okay. Hold on. No, I did something wrong. Whoa. Hold on, guys. That's wrong. I have it flipped. It's backwards. Hold on. The opposite side is x. Wait a minute. Is this right? No, did I do it
So
right?
wouldn't it be x over 15?
Wait a minute, hold on. Did I?
It's
It
x
is
over
no,
15.
I had it right. I had it right. X over 15. Okay, it was right. My bad. I'm on my paper. I'm looking at something else. Yeah, it was right. It was x over 15. Okay, sorry about that. I'm looking at something else on my paper here. Okay, so multiply both sides by 15. So 15 times tangent to 55. Let me see, Jasmine. Is that what I got? Yep, Jasmine. That's exactly what I got. 21.4. Exactly. Yeah. So if you put in your calculator, 15 times 10 to 55. Yep, 21.4. Guys, I wanna do one now where because here in these problems that we've done so far, the variable that we're looking for has been in our numerator. But I want to do one where the variable's in our denominator because I want you guys to see how to solve that as well. Ramaya, what is your question?
Okay, like for the ones without the box in the corner, like how will we know if it would be a opposite side or
Okay,
any of those three? How will we know?
well, so the only thing the box in the corner tells you is which one is your 90-degree angle. That's the only thing it tells you. And so you just always know the hypotenuse is your across from that. But the like for example, if you look at J, um, you can easily figure out which one is the hypotenuse just by looking at
The
um,
longest.
the longest side. Yeah. So Ramaya, as far as knowing which one is the adjacent side and the hypotenuse, I'm sorry, the adjacent side and the opposite side, in order to know that, you always look at the angle given. So for example, here, they tell you this is our angle, which is 68 degrees. So you want to say, okay, which side is touching that angle? If it's touching it, it's adjacent. If it's across from it, it's the opposite side. Okay? That's how you know.
Okay.
Yeah. But yeah,
Thank you.
not a problem. Good question. Like I said, the only thing the box just tells you is which side is this an 80-degree side, which helps you find the hypotenuse, but you can easily figure that out by looking at the longest side. All right, guys. Let me do one more. I think if I do one more with you guys should be good. Let's look at L. L is a good one. Let's look at L. Okay, so in situation L, okay, remember what I said. What you want to do. You want to label. You want to start off by labeling all the sides and labeling the angle. So our angle theta here is 55 degrees. Okay, and what else is important? Well, this side right here is obviously my what? Mine.
Hypotenuse.
Yes, ma'am. Hypotenuse. What would this side be?
Opposite.
Yep, because it's across from the angle, right? It's across from the 55 degrees. Okay. So guys, which equation includes the terms opposite side? Well, includes the opposite term and the hypotenuse term out of the three. And
Sine.
Courtney, sine, exactly. So for situation L, you know that sine of our angle theta is equal to opposite over hypotenuse. So let's plug everything in, guys. Our angle here is 55 degrees. Sine of 55 degrees sine of 55 degrees is equal to our opposite side. Our opposite side here is 375. And our hypotenuse is x. Now I want you guys to notice something. In the previous problems we were doing, x was in our numerator, but here x is in our denominator. So how do we algebraically solve for this when x is in the denominator? Well, I'm telling you guys right now, in order to solve this using algebra, what you want to do, you want to get it out of the denominator first, and then continue the remainder of the algebraic steps to get it by itself. So I want to get x out of the denominator. The way I do that, I multiply both sides to equal sign by x. I'm going to multiply this by x. So if I do that, that goes away. And whatever I do to one side, I have to do to the other. So x times sine of 55 degrees is equal to 375. So there you go. So I've gotten x out of the denominator. Now that I've got it out of the denominator, I need to isolate x. I need to get x by itself. In order to do that, I obviously have to divide both sides by sine of 55 degrees. That goes away. When I do that, whatever I do to one side, I have to do to the other. So that means I'm just left with x is equal to 375 divided by sine of 55 degrees. That's what you want to put in your calculator. 375 divided by sine of 55 degrees. Guys, this is how you enter that in your calculator on Google. So you want to type in 375 first. 375 divided by, and of course I'm going to put parentheses here. So 375 divided by, and I'm going to hit sine of 55 degrees. Okay. And I'm going to hit close parentheses and then close parentheses again, right? So I'm dividing this whole thing by sine of 55 degrees. Okay. So 375 divided by sine of 55. When I press equal, notice what I get. I get 457.8. So that means for this problem right here, for situation L, x is equal to 457.8. So that is for situation L. Any questions for me? Everybody, does everybody feel comfortable with this? Do you guys, y'all think I got this down? Y'all understand everything that I did? Are we good? All right. So Jasmine says she's good. So I assume everybody else, y'all are good. All right. Thank you, Jade. All right. So guys, if you're good, why don't you just go ahead and just complete the rest on your own? Again, like I said, don't worry about drawing any triangles. My whole thing is I just want to see that you guys are setting your equations up correctly, like you're choosing the right equation and you're putting everything in the right place. And I want to see that you guys know how to work out the problem. So I just need for you to show your work and give me the solutions. And again, you're doing A through Q. They don't necessarily have to be in any particular order, as long as I see that you guys know what you're doing and that you guys are good. Again, I just want the correct solutions and the work. Typically, guys, what I would have done, I would have made this due tonight by midnight. However, my 8A class, I gave them some extra time because yesterday there was a fire drill, and I didn't get finished recording the video, so I wasn't able to post the video for my 8A classes, and so I just told them I would extend the time. That way, they can look at the video first if they need to, before they get it done. So since I'm going to post this video on today, I'm extending the deadline for them. And so if I'm extending the deadline for them, I'm going to extend it for you guys as well. So this assignment is due by Friday, tomorrow, midnight. Not today midnight, but tomorrow midnight. But if you get it done and turn it in on today, that's fine as well. Okay. In fact, I would prefer that because I can go ahead and start getting these graded. All right. So if there are no questions for me, you guys are free to go.